Welcome to Science Tree channel, and today's topic is Alkynes from chapter number 12, class 10th. What are alkynes? Alkynes are a class of hydrocarbons containing only carbon and hydrogen, unsaturated compounds with at least one carbon-to-carbon triple bond. Now in this definition, the word unsaturated requires explanation. The word unsaturated means that there is a space, okay? There is some accommodation available for other atoms. Alkynes have triple bond in them, in which one of the bond is a sigma bond, while the rest of the two bonds are pi bonds. These pi bonds are weaker than as compared to the sigma bond, and definitely these pi bonds will break and give a space for other atoms. When these bonds will break, free electrons will available, and these free electrons will provide a space for the addition of other atoms within them. Okay, so that's why alkynes are considered as unsaturated compounds. They are more reactive compounds. This is acetylene, having two carbon atoms in it with two hydrogen atoms, and triple bond is present between two adjacent carbon atoms. In this triple bonding, two of the bonds are pi bonds and middle one is a sigma bond. Carbon satisfies its valency. Carbon can form four bonds. Having positive 4 valency belongs to group number 4A. Now, one of the bond is formed with hydrogen atom and rest of the three bonds are formed with other carbon atom. In this way, this is a compound with formula C2H2 known as acetylene. They are reactive because pi bonds will break and give accommodation for other atoms. Its general formula is CnH2n -2. The general name used for alkynes is acetylene because the name of the first member of the series is acetylene, having two carbon atoms with two hydrogen atoms. Now the names of the alkynes with their molecular formula: ethyne, propyne, butene, pentyne, hexyne, heptyne, octyne, nonine, and decyne. The word eth is representing two carbon atoms. Prop is representing 3 carbon atoms. But is representing 4 carbon atoms. And pent is representing 5 carbon atoms. And so on. While yne is representing alkynes, it means triple bond present in them. And please remember, more the number of bonds, less will be the hydrogen atoms. So here in alkynes, the triple bond is present between two adjacent carbon atoms. So that's why the number of hydrogen atoms are lesser than as compared to alkenes and alkanes. Now this is a beautiful chart showing molecular formula, condensed formula, structural formula, and cross and dot formula of alkynes. In my previous videos, you can watch and memorize in detail about all these formulas. Now, acetylene having two carbon atoms with two hydrogen atoms. So in molecular formula, we are not able to see bonding, okay? But when we move forward in condensed formula, here in condensed formula, the bond present between the carbon and hydrogen cannot be visualized, but the bonding present between two adjacent carbon atoms, triple bonding, can easily be visualized. So in this way, in condensed formula, we are able to see number of bonds between two adjacent carbon atoms as well as number of atoms and which type of an atom is using in making a compound. Okay? Now in structural formula. In structural formula, it is more elaborated. We are able to see the bonding present between carbon and hydrogen as well as the bonding present between the adjacent carbon atoms. While in cross and dot formula, everything is visualized. The number of electrons participating from each atom can easily be understood by means of cross and dot formula. Now here the carbon is representing its electron by means of dots and hydrogen is representing electrons by means of cross. So now in this way we can say that each hydrogen and each carbon is satisfying its valences. Now the next compound is methyl acetylene. The word methyl acetylene means that 3 carbon atoms. For 1 carbon we use the word meth. For 2 carbons we use the word acid. And here we have 3 carbon atoms. So the both joins together to give us prop. And it will gonna be named as propyne. Now in the third example, this is dimethyl acetylene, or we can say butane, having 4 carbon atoms in it, having the condensed formula, structural formula and cross and dot formula over it. Now we discuss about the occurrence of alkynes. From where we get it? Acetylene does not occur free in nature. Traces of acetylene are present in coal gas, about 0.06%. Alkynes found in nature in plants and in some animals and possess physiological functions. Most of the steroids are alkynes, and a poisonous rat secretes some alkynes from its skin, which can cause convulsions in mammals. So in this way, alkynes are present in plants as well as in animals, but they are not found in free state. How can we prepare alkynes? Preparation of alkynes. Larger alkynes can be generated by reacting an alkyl halide with an acetylide, which is generated from a shorter alkyne. What does it mean? The word alkyl halide means that carbon with halogen, and acetylide means whenever one of the hydrogen or one of the proton from the terminal carbon of acetylene is removed, it will gonna be changed into acetylide. So this acetylide, when react with alkyl halide, it will give larger alkynes. Dehydrohalogenation of Vicinal dihalide. The word D stands for removal, and the word hydro is representing hydrogen. The word halogen is representing group 7A, chlorine, fluorine, bromine and iodine. Now, dehydrohalogenation of Vicinal dihalide. Here the term comes vicinal, and the word vicinal means when any functional group, any halogen is present on 2 adjacent carbon atoms. It means it's vicinal. Now here we have halogens, so we will gonna name it as vicinal dihalide. Another term which is also used but in opposite sense, that is geminal. Okay, geminal dihalides. But it can be a geminal dihalide when both the halogens are attached with the same carbon atom, not with the adjacent carbon atoms. So whenever the functional group is attached with the same carbon atom, it will gonna be named as geminal dihalides. And when the halogens are attached with the adjacent carbon atoms, they will be known as vicinal dihalide. Now here what we are doing, we are making alkynes. For that, we are treating it with potassium hydroxide in the presence of alcohol at 100 degrees. Now we know that potassium is a cation and hydroxyl is an anion. Potassium will form a bond with chlorine, as chlorine is negatively charged, and the positive and negative will attract each other. So a bond will break from the carbon number 1 and chlorine will free to form a bond with potassium. On the other hand, on the second carbon, from here the chlorine will break. So from both of the carbon atoms, chlorine will break and form a bond with potassium. As here we have 2 potassium ions and 2 chlorine ions. So both will react together to give us potassium chloride. While hydroxyline, which is negatively charged, will form a bond with hydrogen atoms. Now these hydrogen atoms will break and form a bond with hydroxyline to give us water. Free electrons of carbon will form bond with each other and give us ethyne. Triple bond compound between 2 carbon atoms will be named as ethyne. So in this way, we can prepare alkynes with vicinal dihalides. While the second method is dehalogenation of tetrahalides. Now this is tetrahalide having 4 halogens with it, 4 chlorines attached with it. Now these 4 chlorines will remove and form a bond with zinc, changed into zinc chloride. When this bond will break, carbon have its free electrons available. So these free electrons on adjacent carbon atoms will form a bond with each other and give us ethyne. So this is an elimination reaction, okay? Thank you so much. For more videos, keep watching. Have a great day.